Okay, so on this video I'm going to explain about almost everything about scalar product and cross product. Okay. Okay, so the dot product of two vectors, u vector and v vector, is defined by the magnitude of the first vector multiplied by the magnitude of the second vector multiplied, sorry, I need to write a dot here, not a cross, so that here. Okay, whatever. Multiplied by cosine the angle of these two vectors, which is equal to the product of sum of the coordinates. That is, if you have the coordinates of each vector, that is xx prime plus yy prime plus zz prime. Okay, if the two vectors are perpendicular, for instance, this is a vector and this is another vectors, and they are perpendicular, then the angle between these vectors, the two vectors, is 90 degrees. And we all know that cosine of 90 is equal to 0. So, the dot product or the scalar product of two perpendicular vectors is equal to 0. If the two vectors have opposite senses, then the angle between them is equal to pi, or 180. And we all know that cosine of pi is equal to -1. So their dot product is equal to negative the magnitude of the first vector multiplied by the magnitude of the second vector, and this is it. If we have two vectors that have the same direction, this means that the angle between them is 0. So cosine of 0 is equal to 1. So it's simply the product of the magnitude of the two vectors. Cosine the angle between two vectors. So simply take this to the other side by dividing by it on both sides. You get that cosine of theta, let theta be the angle between the two vectors, is equal to u vector dot v vector over the magnitude of the first vector multiplied by the magnitude of the second vector, is equal to xx prime plus yy prime plus zz prime over the magnitude of the first vector multiplied by the magnitude of the second vector. Okay, the magnitude of a vector, we all know that the magnitude of a vector is equal to the radical of the components of the vector's components or coordinates squared. So it's radical x squared plus y squared plus z squared. Then in this case it's equal to radical x squared plus y squared plus z squared plus x prime squared plus y prime squared plus z prime squared. Why do we call it scalar product? The reason why we call it scalar product because the resultant product is of a scalar quantity, meaning having only magnitude and not direction. Note that in scalar product, u vector dot v vector is equal to v vector dot u vector. So if you reverse the vectors, it doesn't matter, because cosine of theta is equal to cosine of negative theta. Vector product or cross product. A very important note that in cross product, unlike in the scalar product, so the cross product of two vectors is equal to another vector. So it has direction and magnitude. It's not only a scalar quantity. So in this case, the cross product of u vector and v vector is another vector, c vector, perpendicular to the plane formed by u vector and v vector. So the u vector cross v vector is equal to the magnitude of the first vector multiplied by the magnitude of the second vector multiplied by sine the angle between the two vectors. Okay. By convention, while naming, we take that the anti-clockwise direction is the positive direction and the clockwise direction is the negative direction. What I mean is that, note that u vector cross v vector is not equal to v vector cross u vector. It's equal to negative v vector cross u vector. So, for instance, when we're saying here u vector cross v vector, we're naming in an anti-clockwise direction. So that's why it's equal to positive c vector. If we said v vector cross u vector, then it's equal to negative c vector. Okay, so the area of the parallelogram formed by u vector and v vector is equal to the magnitude of c vector. So it's equal to the magnitude of c vector. Okay, let's name O as A, here B and here C, and draw the diagonal, and the midpoint of that diagonal. We all know that AB vector plus AC vector is equal to the diagonal of the parm, which is equal to 2AO vector. So let's draw it and name it as D. And this is the parm. And this vector right over here is perpendicular to this plane and perpendicular to every line and vector in this plane. So the magnitude of this vector is equal to the magnitude of the cross product, which is this vector, equal to the magnitude of the first vector multiplied by the magnitude of the second vector multiplied by sine the angle between the two vectors. What is the area of the triangle from one diagonal? For instance, this triangle. It's simply the area of the parm over 2. So it's the area of the parm over 2. So it's u vector cross v vector over 2. An important note is that, for instance, if we have 3 points A, B, and C, that's 3 points A, B, and C, and we need to prove that these 3 points are coplanar, meaning that they belong to the same plane. If you want to prove them that they are coplanar, what we should do is AB vector cross AC vector shouldn't be equal to 0. Because any 3 non-collinear points form a plane. If it was equal to 0, so if the question was prove that the 3 points are collinear, A, B, and C, for example, AB vector cross AC vector will be equal to 0. So the vector here will be equal to 0. It won't appear. Because the angle between AB vector and AC vector is equal to 0. And sine of 0 is 0. And if the vectors were opposing to each other, then the angle is pi or 180, and sine of pi or 180 is equal to 0. Okay, sorry, I forgot to put a vector over here. This should be equal to 0 vector. Okay, so let's continue. Let's solve these exercises. K vector cross J vector, we're moving in a clockwise direction while naming, so it should be equal to negative I vector. I vector cross J vector, we're moving in an anti-clockwise direction, so it is equal to K vector. K cross I vector, we're moving in an anti-clockwise direction, so it's equal to J vector. Of course, J vector cross J vector is equal to 0 vector, since they have the same direction, same to all of these. You can continue them for practice. Okay. How can we calculate the cross product of two vectors? What we mean here is to calculate the coordinates of the vector perpendicular to the vector formed by the cross product, that is perpendicular to the plane formed by u vector and v vector, or perpendicular to the parm in this plane, which is this plane. Okay, so first we start by putting two lines and put the unit vectors I vector, j vector, and k vector. Put the coordinates of the first vector, let x, y, and z be the coordinates of the first vector, x prime and y prime and z prime be the coordinates of the second vector. Then what we do is put positive I, I'm gonna circle this positive sign, and okay, so I is located in the first row and in the first column, so cross them out. So what remains is this portion. Write what remains. So y prime and z prime minus, I'm gonna circle the minus, j vector, sorry. Okay, so J vector is located in the second column and in the first row, so cross them out and put what remains. So that is x, x prime, and z, z prime. Okay, plus k vector, cross them out, put what remains, circle the positive. Okay, what remains is x, x prime, y, and y prime. Okay, so if you have a matrix that is A, B, C, and D, we calculate this matrix by multiplying A and D minus C times B. So it's AD minus BC or CB, whatever. Okay, it's equal to I vector into YZ prime minus Y prime Z minus J vector into xz minus x prime z plus k vector into xy prime minus x prime y. And then you calculate the coordinates of the vector. Okay, and doing this process, this step is useless. You can do it mentally when you become fast. You can imagine crossing them in your mind and multiplying them. And that's it. Okay, let me erase these. Okay, on a piece of paper, try to solve this for practice. I'm going to solve it really fast. U vector cross, is equal to, put the two lines, put the unit vectors, put the coordinates of the first vector, put the coordinates of the second vector, positive I into 2 times negative 1, that's negative 2, minus 8, that's equal to positive 8, minus J vector into, that's negative 1, negative 2, plus K vector into, that's 4 plus 2, which is equal to 6. Okay, so you will get a 6i vector plus 3j vector plus 6k vector. And these are the coordinates of the vector perpendicular to the plane formed by u vector and v vector. Okay, on to mixed product, or what we call triple product. We use triple product for many things, such as to calculate the volume of a tetrahedron, or proving 4 points to be coplanar or not. Okay, so calculating the mixed product is very similar to the cross product. We put the coordinates of the first vector, the second vector, the third vector, x double prime, y double prime, z double prime. Sorry, I'm writing with the mouse. So it's equal to positive x, eliminate them in your head, y prime, z prime, double prime, minus y double prime, z prime, minus y into x prime, z double prime, minus x double prime, z prime. Okay, continue it on your own. Oh, خلاص, I will write it. Plus z into x prime, y double prime, minus x double prime, y prime. And this is the formula. Okay, so let A, B, C, and D be three points in a plane P. And we need to prove that these 3 points belong to the same plane. What we do is do the mixed product which is the cross product of any two vectors in this plane, which is going to give you a vector perpendicular to the plane dot or dot product with another vector that is on the plane, and that should be equal to 0 because the vectors will be perpendicular to each other. So in this case it is equal to AB vector cross AC vector, or any vector in any two vectors in this plane, dot, for instance, AD vector. And if this was equal to 0 vector, then those 4 points form a plane. And if it wasn't, then these 4 points can form a tetrahedron. So to prove that 4 points form a tetrahedron, prove that their mixed product is not equal to 0. Okay, so the volume of a tetrahedron DCAB. I forgot to see here. Okay. The volume of any tetrahedron is equal to 1 over 3 the area of the base times the height perpendicular to the base. So this height for instance, or this height. So it's equal to 1/3 the area of the base. The area of the base right over here is equal to AB vector cross AC vector over 2. Why is it over 2? Because it's a triangle. So the area of the palm formed by AB and C, for instance, whatever, a point over here, is equal to AB vector cross AC vector. The magnitude of this area. So over 2, and that is equal to the area of the triangle, which is the base of the tetrahedron. So AB vector cross AC vector over 2 dot, so it's the scalar product with any of the tetrahedron's sides to get the height. For instance, DC vector. And that will give us 1 over 6 AB vector cross AC vector dot CD vector or DC vector. And this is how we use the mixed product to calculate the volume of a tetrahedron DCAB. Thank you for watching.